Welcome to this special edition of Botcast powered by Smartbots, where we explore the exciting world of technology, innovation, and the future of AI. I'm Mansa, your host, and today we have two distinguished guests with us. Our first guest is an accomplished product lead and data scientist with over 11 years of experience in data science and systems engineering domain. Welcome to the podcast, Rajesh Gupta.
Yeah, thanks, Mansa. Thanks for having me over here.
Rajesh, please share your journey so far and how you have entered the world of data and AI.
Sure, Mansa. So, my journey started in the very early days of the machine learning. Let's go back in 2010. I started my graduation from University of Maryland. After graduating, I joined Qualcomm in 2012. During that time, few years down the line, I started working in the data science domain, mostly on the wireless optimization side of it. And later on, I joined Apple back in 2018. Mostly, I switched the gears, and now instead of wireless, I was more on the cybersecurity side of it. And my responsibility was more on the fraud detection, specifically on the digital identity side. And there, not only we build the algorithms, but also we build the application at the enterprise scale. And 3 months back, I left Apple to start my own gig, and that is also in the large language models.
Thank you, Rajesh, for sharing your impressive background. And moving on to our second guest was JP, a key player at Smartbots. He's a true expert in the field of chatbots and AI integration, and he's here to share some valuable insights with us today. Welcome to Podcast, JP.
Hello, Mansa. Thanks for having me here.
JP, could you please provide an overview of your background for our audience?
Yeah, sure. I carry about 13 plus years of experience in the software domain. I was a developer by profession and by passion as well. And for the past 5 years, I have been actively involved as a solution architect. I have been helping enterprises solve their business problems using technology. And primarily, the solutions that I was drawing around were building chat and voice bots for enterprises. And also, parallelly, we are developing a conversational AI platform. This is a SaaS platform that I am the solution architect. I also have experience in data science and machine learning. I'm a AWS certified machine learning specialist. I understand deep learning, generative AI. This year has been really special because the large language models have caught the entire world like wildfire. And this makes me really excited. The reason is that we got new set of tools for solving really complex business problems. So that's about me. I'm really passionate about solving enterprise problems in a nutshell.
Excellent. I'm going to turn the spotlight over to JP, who will be steering our discussion today. JP, the floor is yours.
Thank you. So, Rajesh, let's get going. I'm sure both of us are so deep tech. So, I'm sure I think I can directly jump onto the technical aspects of this discussion for today. We will deep dive into large language models, focus on the number of parameters, what factors businesses should consider, then what is RAG, what is model fine tuning, so on and so forth. So it is going to be, I mean, I'm sure both of us will be comfortable speaking this language. So my first question to you is, these days we hear that there are a lot of large language models, and associated with each of these large language model is model parameters. We hear OpenAI's GPT-3 or 175 billion parameters, and then GPT-4, I don't know how many billion parameters. Then Llama has around 180 billion parameters. These billion parameters are something which have the identity in itself. Like if the bigger the number, the models are considered to be like really powerful. But as such, do these numbers really matter if you are from an enterprise standpoint? If I'm an enterprise and I have to pick a large language model, should I always go for a large language model that has the highest number of parameters? What is your take on this?
That's a very nice question, JP. We need to understand that are you a business person or a technologist? If you're a technologist, yes, definitely try to play around with the number of parameters and the different models to understand, okay, which model works fine. But in a business, typically, the goal is not to fit the technology. The goal is to solve the problem. So my answer for this question is no. Choosing the right LLM model should not depend on the size of the model or the number of parameters. It depends on what you are building. Suppose, let me give you an example over here. So if you are building a sentiment analysis on your customer reviews, your previous traditional small language models like BERT can play a very good role over here. So why to bring the canon in the house?
Sure, I think that's the valid point. We don't need a large model for all business problems. We'll have to pick and choose the right size model. Now, taking this further, what other factors should the businesses consider while, say, choosing an LLM? We have like 1,000 plus large language models available. Hugging Face has made them available. AWS has made them available in the form of foundation models in collaboration with Hugging Face. So there is an access. They are, to a great extent, are getting democratized. Now, as an enterprise, what factors should I consider while picking one model over other?
Yeah, definitely. So think about, like, first I would like for the audience, I'll like to categorize this large language models into three different buckets. One is API based large language models, which are like a OpenAI 3.5, GPT 3.5, 4, or Anthropic Claude. There's another set of large language models which are like a open architecture models. I usually say that those are like Llama 2 or the Dolly. And then the typical language models, which are like a small language models, which are like a bird. So these are typically the classification of the language models. But now which one to use depends on quite a bit of factors for the business. Number one is the performance, that how good is this model on your data set, not on benchmark data sets. And then there's a cost, latency, data privacy. These are another critical issues as well when you're running the application. But I would add one more parameter over here, criteria over here to choose the right model is the in-house talent, because these models are very big in nature, large in nature. So deploying these models and maintaining these models also requires the right talent, and hence having the in-house talent also defines that okay, which one to go with.
Sure. So what I hear from you is, in addition to the factors like data security, the latency, the use case, and also you should consider in-house talent availability because you need the right set of talent to handle this large language models.
All right.
Let us take one particular use case. Since I deal with chat and voice bots, I'm more interested in enterprises who want to deploy a chat bot. Sometimes it looks like, okay, it is these large language models are exceptionally good in building an application like a chat bot, right? But is that correct? So can I directly integrate a large language model and build a chatbot out of it? What? How do I pick a LLM? Can I pick any LLM and build a chatbot, or what is your take?
It's an interesting question because first, I would like to give a little background on the chatbots. These chatbots are a very old use case in the machine learning world, but machine learning, it was a very complex design in one way, right? You had to do the data preparation, you need to do the intent classification, you need to have a domain expertise to do the feature engineering. And apart from that, there are many other issues, like there was a coverage issues, there are multi-language issues. And that too, when you are doing all those things, you are still building for a specific task, and hence the previous versions of the chatbots were not growing well. Now, large language models, which are really good in the context comprehension, is playing a big role in the chatbots. Now, what models to pick, what metrics should be considered over here? Going back to the same analogy, that there are some API based models where the infrastructures are being handled by the companies like OpenAI and the Anthropic. There's another open architecture models, which are you have full control on those models, but at the same time the onus on deployment and the maintenance is on you. So that is second thing. And on top of that, like a metrics is very relative, because state of an art is definitely nowadays for many of the organization is on the API side GPT 3.5, GPT 4, or Anthropic Claude. Open architecture side, it is like a Llama 2 or some case Dolly as well. So these are the state of an art. But out of these models, which one is right for you? Which one you need to pick? Going back to my previous answer, same thing: performance, cost, latency, and your in-house talent. Right now, coming back to this point that okay, these are the things. Along with that, your own data set also matters a lot, because if you go with those benchmark numbers by default, you will say that GPT-4 is good, but may not be good for you, because your data set is very different, your application requirement is different. GPT-4 has latency as well, whereas in some cases it has been seen that 3.5 works better than GPT-4. So, evaluating the performance and the different other factors on your own data set on the state of an art model, if you're not planning to pick all those 20s or 30s of different models out there, start with these 4 or 5 state of an art models, evaluate the your performance on your data sets, and take the right decisions accordingly.
Great, that's interesting. So, for chatbots, what I hear is there are a set of, I mean, maybe not a standard set of models, but the most common ones which are good at solving the chatbot kind of a problem, and we can start with them and evaluate and see. So, moving to a related topic on document search, where we implement RAG, retrieval augmented generation. For the audiences, the concept of RAG, just to give. Moving on to the next question, which is about document search. We have a concept called RAG, retrieval augmented generation. Just that everyone understands what RAG is. RAG is the concept in large language models which has emerged, where you large language models not necessarily have answers to all the questions. So therefore, the concept of RAG would solve in those cases where you give the context, and from the context, the large language models will be able to get the answers. So talking about RAG, Rajesh, my question to you is: can RAG is RAG a perfect solution for say document search kind of a problem, or do you see any challenges in RAG as well?
So RAG is basically an implementation type. It is not a solution. I would say I will call it out as a solution, because solution is ultimately your application, and RAG is one of the way to build your application. To give little more context on what you said about RAG is for the audience that RAG means retrieval augmented generation. So that means is you are retrieving something first, and then using that you are generating your information. Why it is needed, first of all, to understand, and that because that helps to answer this question. So the typical flow in the large language model is you have a prompt, you pass the data and the prompt to this large language models, and this large language models generate a context. Now this thing works very well when you have a comparatively smaller data set, because large language models has a some kind of a limitations on how much input data that it can handle. Now, in many cases, like you mentioned, JP document search, that organizations do have huge amount of documents. Now, this huge amount of documents cannot go to this large language models directly. So, what this RAG implementation does is you first retrieve the chunks from this data sets, the huge data sets, and this retrieved chunks you passed it with your prompt into these large language models to generate the context. So there is an additional step, if you see over here, is the retrieval part. Now coming back to your question is that okay, is this the only solution, or how to measure this solution? So this is not the only solution, but this is one of the easy and the best solution to get your application out. The reason is, so what are the other solutions? First of all, try to understand. So typically, one, you can do the prompt optimization or the prompt tuning. Second, you do this RAG, and third, you do the fine tuning, and fourth is you train your models from scratch. So Last option is not available to 99% of the organization because training the large language models from scratch is not a easy affair. It requires both resources and the money. So fourth option is almost negligible, almost not there for organization. Now, out of these three options, prompt engineering plays a very good role. Many people are doing it, but as I mentioned, if you have a large amount of data, prompt engineering may not help. Then you are left with only two options: a RAG and fine tuning your models. Now, a RAG is the simplest way because of multiple reasons. One, your data gets evolved now and then, so you don't need to worry about training your models every day. Second, it's comparatively easy to implement and easy to deploy than your fine-tuned models. So, because of that nature, RAG is becoming one of the state of an art into the chatbot implementation or the document search. Now, coming back to the another point, okay, how should we measure this RAG? So that again, going back to the analogy that how RAG works. So think about RAG. RAG has three steps involved. You pass the question. Based on the question, you get the retrieved chunks. This retrieved chunks goes to the model and generates some response. Now, since it has three steps, it requires to be evaluated or measured at the three steps as well to understand the end-to-end thing. So what does it mean? So you need to measure that the question that you are passing and the retrieved chunks that are getting out is actually relevant or not. Using these retrieved chunks, you are generating the response. Now this generated response, how good is that response corresponding to this retrieved responses? Or is it generating more things from the retrieved responses, or is it missing something which are not even there in the retrieved responses? And the last but not the least is your generated response. How good is that generated response corresponding to your original question, user question? So having these three areas of measurement in the RAG is very important to understand the overall performance of your RAG implementation. And based on that, then you can decide that okay, what actions I can take. Either I can go back and do the prompt tuning, or I can go back to improve my retrieval models, or I can go back to do improving my language models as well. So on the language models you can do the fine tuning, or you can select the different models. All those things are possibility after that, but measurement is very important before taking the right action.
Great. So, just to summarize the points that we have covered so far, what we have understood from you so far is that we need to pick the large language model not just based on the number of parameters but considering multiple factors. And based on the use cases, say if you take chatbot as a use case, there are few most common large language models that we can that enterprises can start trying out, measure, and then pick the right one that fits their use case. And moving on to the application of when we move to the document search kind of an application development, which could be part of a chatbot application. There are techniques like RAG, which can help in quickly get into the production grade version of the solution. While there are other techniques like prompt engineering, fine tuning, and even building a large language model, the one which is easy and quick is easy and of good quality is retrieval augmented generation. And again, for RAG as well, on a case to case basis, you'll have to measure and take the right call based on the use case.
Correct.
So the last topic that I have for this discussion is on the hallucination. I was talking to someone recently, and the point which that person, he's also a data science expert. His point of view was hallucination is not a bug; it's a feature, and that's the essential DNA of a large language model. That was an interesting way to look at hallucination. On the other side, when I interact with enterprises, I see that as a concern. Like enterprises shy away, saying that we need the chatbot, or any other large language model application to be right 100% of the time, because there is an impact sometimes on their brand, sometimes even it goes to the extent of legal complications. So now I want to understand your views on hallucination first. How do you view hallucination as such? And then how do you measure this hallucination? Are there any techniques? Are there any data science approaches towards measuring hallucination?
It's an interesting topic because, and that is one of the thing I've also seen in the industry so far, that because of such concern, people are not able to move their application from the POC to the production, because everybody is one or the other way is kind of a scared. So I believe it requires two important things to understand. One, the organization also need to be educated on this perspective, and second is, as an application developer, we can take some of the actions to basically reduce or to some extent prevent the impact of the hallucination. So what are those things? So first is the education. Like everybody needs to understand that when we are dealing with machine learning or the large language models, we are in the world of probabilistic, not in the world of deterministic, like a software engineering. So 100% having a guarantee of 100% is very vague, because achieving 100% in the probabilistic world is very very difficult. But at the same time, there are ways to the impact of the hallucination on your brand image, on the user impact, on the user trust, and all those things. But as you said, correct, hallucination is not a bug, it's a feature in the large language models. And hence, at the model level, it cannot be prevented, it can only be measured. So that once you measure it, you can take the right actions. Now, going back to two topics. One is how we can measure it, hallucination, and second is how we can prevent it. So the measurement part is like the best approach, which everybody believes is the human evaluation. But human evaluation also has its limitation, as people need to understand it. We evaluate based on human. We evaluate major concerns like correctness, relevance, and all those parameters. But at the same time, we missed out a lot of other parameters or the factors because of the human mindset that we cannot do all the coverage. Like simplistic could be starting with the word count to the complex on the side of the bias, racism, and all those factors. So, which are very difficult for the human or the developers at their point. Second piece is, since we said hallucination. Hallucination, defining the hallucination is very important. That what do you mean by hallucination? Is it the randomness in the response is the hallucination for you, or is it the incorrect response is the hallucination for you, or many other things? So, and that is what human is also measuring when they are evaluating it. So now, how you can measure it? One, you can have your army of developers sitting on all these responses and considering the different aspects of the responses to the statistically significant number of times, which is very difficult for any organization. Hence, it requires some kind of a automation as well. Now, this automation, how this automation can play a role? It's a very complex affair, hallucination. I completely agree with that because there is no straightforward definition of it. So, first is you need to define the hallucination, and accordingly, you can define the metrics. For example, you are saying for me, the factual accuracy is the important thing. Now, understanding the factual accuracy, because you're talking about two words over here, factual, facts, and the accuracy. Facts, what do we mean by facts? They are facts which are global facts that everybody knows on the internet, that these are the facts. Like Elon Musk is not a CEO of Microsoft. This is a global fact that everybody knows that. But there is local facts as well, which are very much particular to your organization. Hey, I have this business policy which supposed to work in this particular fashion, and this knowledge is not global knowledge, that is local knowledge. So hence measuring based on that is a different part. Similarly, accuracy, the second word of this matrix, factual accuracy. Accuracy, what do you mean by accuracy? Is it the number of words matching is the accuracy, or is it the context that is matching is the accuracy? So it goes into the very subjective field where defining the metrics is a big challenge. That some of the metrics in the machine learning world where we have the hold on the training data set was comparatively easy because we had the ground truth, and based on those ground truth we had defined some metrics like a bleu meteor and such kind of a metrics, which are very much on number of words matching based on the ground truth, or the context matching based on the n-grams. So those were the things that previously people were doing in the traditional machine learning. But with these large language models, we do not have a control on this training data set. Hence, we do not have a control on the ground truth. So, more importantly, the metrics are getting evolved as well. Those data science metrics can be used. But first, as a business, you need to define it. That what do you want? Or when you say that your application is working good. So it requires some kind of a level of understanding from the organization that, okay, based on these facts, we will do that. Then you define the right metrics and the meaning of it. And hence it's a very complex affair. So it requires some kind of a tools that can incorporate your business guidelines, your business policies, or your requirements in the natural language, because these people, the business people, are very much agnostic to the data science metrics, so they can define their requirements in the natural language. And this tool can incorporate all those natural language policies, guidelines, or the business requirements, and incorporate those into the some kind of a matrix. And based on those metrics, you can evaluate or the measure this hallucination. And once you measure the hallucination, once you understand the impact of this hallucination, you can take the right actions.
Got it. As an extension to this question, see, we spoke about retrieval augmented generation or RAG, and we have all subsequently we have spoken about hallucination. Combining these two together, do you see that is there a possibility of hallucination in RAG as well? What is your take?
Yes, the same steps are happening in the RAG as well. It is just the implementation difference is there. So going back to the same RAG, step number one, retrieval. So how well your retrieval is happening, that is also based on the language models. Many people are using the small language models, but they can also be probabilistic in nature. So understanding how well your retrieved responses are coming based on your question is the part where you need to measure it, because that can also to some extent hallucinate. Then you're passing your retrieved responses to these large language models to generate something. Think about, you're again generating something, so that can also hallucinate. So over there, having the right metrics, maybe the relevance or the correctness, or maybe the number of words, or maybe the facts, that these facts should only come from the relevant chunks. So those are again the other side of the metric. So hallucination is happening. In fact, RAG is very critical because you need to measure at three different steps instead of one. So it's a very critical area on the perspective of the hallucination.
Great. I think this is really insightful so far, Rajesh. And what I understand is initially, when this beginning of the year, when ChatGPT came into the limelight, it looked everything was a cakewalk. But understanding the science behind this, understanding the various factors to take a business decision are extremely important, and it is extremely important for the enterprises to invest time and effort in understanding large language models so that they can take benefit of this state of the art technology. Thank you very much for your insights. These are really valuable.
Thanks, JP. Thanks a lot.
Thank you, Rajesh and JP. We appreciate your time and your expertise on podcast today. But as we bring this episode to a close, would you kindly share your concluding thoughts? Rajesh, you can go first.
My thought is basically these large language models are helpful for many of the things, but at the same time, I would strongly suggest that the people should also get educated. It is not that easy that you are just passing some prompts to these models and getting some response, and that's pretty much it. Understanding the nuances, understanding the probabilistic nature of this model is very important to take the right decisions and to apply into your organizations. But at the same time, the organization should not scare because it is something which is very powerful, came out after a very long time and enabling many of the people and enabling many of the applications, which was not the case. So act fast, act smart. That is the only keyword to stay in the business.
JP?
I think Rajesh has summarized it really well. Enterprises should be vigilant and understand this technology to before jumping into real big use cases. So the standard approach, crawl, walk, run approach is what I would recommend to enterprises. Start with a POC, get a sense of how this large language models are going to impact or solve a business problem, measure it, and then take it to production. I think that is what I would recommend to the enterprises.
Would like to express our thanks to both Rajesh and JP for sharing your valuable insights today, and from discussing how business should choose large language models for tasks like chatbots to exploring the assessment of RAG implementation and the challenges of ensuring factual accuracy in AI. Your inputs have, I think, definitely has offered our audience a valuable, diverse perspectives. And saying that, this concludes today's podcast. We hope you found it informative and inspiring. Stay tuned for more exciting discussions in the world of technology, innovation, and AI. Thank you for viewing.